fellow learners, welcome to Education Program Online with me, Teacher Christine, taking you in Mathematics for Senior 3 and Senior 4. So my dear learners, we are still continuing with our lesson topic, that is real functions and limit, but we are based now on limits. So in our previous lesson, we looked at what we called rational limits. Rational limits. Rational limits. Rational limits. Where we said that when you look at the rational limits, it simply means division of functions. Division of functions. And we said that when division of functions takes place, it means that the two functions which have been having a mutual relation are being now divided. And when they are divided, then we simply say these are now limits. There is a limitation for me or to the two variables to continue in a good relation. So that is situation we term it as limitation or limits of a function. And then I want you to remind you that when we are looking at the rational limits, we say there are two things that happen. You find that x will approach to what we call infinity, or x will approach to 0. So in that situation where x is approaching to 0 or infinity, what are you supposed to do? You are to divide all the given terms of your function by the highest power. Then after division, then you can now do what? You can substitute the value of x, which is infinity. And then we remain with the second part of rational functions, that is when x is approaching to a what? X is approaching to a real number. What do? So when x is approaching to a real number, for example, we say find the following. Find the following, and then they say x is approaching to we say lim x is approaching to 2, and then we have x squared minus 4 over x minus 2. So this is a review on where we stopped from. So this part where x is approaching to a real number, not to a infinity. Now what are you going to do? We said in this case you are going to factorize. We are going to factorize the numerator so that you can deal away with the division first before substitution, because you cannot substitute or find a solution to a problem which is divided a half, or it is has a division kind of a statement. So what you do before you do substitution, first eliminate the division sign. So when you eliminate division, then you can easily now be able to get the solution to the statement. Now what do you do now for this case? We said we have to factorize. We have to factorize what? We have to factorize the numerator. And by the way, when we are factorizing the numerator, the factors that you get of the numerator one of it must be the same as that one of the denominator. So we say lim x is approaching to 2 when x squared minus 4 over x minus 2. So you factorize. You only factorize what? You only factorize the numerator, that is x squared minus 4. So when you are factorizing, we said for this case we simply use what we call the error and trial method, which is shorter for you to get the solution. And if we are using error and trial method, it means you are going to break the first term and the third term. Now for this case, we have only two terms, meaning that the middle term is not there. Now what do? You get the common factors for these two terms. So when you are getting the common factor, you simply break this and say, when you are breaking, you look at the numbers. Which factors can I multiply to give me the main whatever multiple, which is x squared. So we get x times x, and then here we also get 2 times negative 2. Negative 2 times positive 2. So when we multiply this, we get negative 4. When we multiply x times x, we get x squared. So these two factors that we have got, you now simply match them. You will get them in that form. And then now you will have x minus 2 and then x plus 2. So learners, that these are our factors for this numerator. Now when we are going to rewrite it, you will substitute these factors is the same as the numerator. Is going to take the place of the numerator. Then now you say lim, when x is approaching to 2, I will now have x minus 2 times x plus 2. Divide it by the denominator, which is x minus 2. So at that level, you can now be able to eliminate what we call the division sign. So you find that this x 2 of the numerator, x minus 2 of the numerator will cancel with the x minus 2 of the denominator. So when we cancel this, we find that we are only left with the x plus what? Plus 2. So at that level, that is where you are going to do what? Your substitution. Since now x is approaching to 2, it means where x is where you are substituting it with the 2. So then now you simply come and say, therefore, lim x is approaching to 2 will now give me x plus 2, which is the same as 2 plus 2. Your answer will be 4. So dear learners, that is how you deal with the rational functions where x is approaching to any real number. I repeat, you factorize the numerator and so that you cancel the division. After that, you substitute. Then now, from that, we are moving to what we call the using rules in rational functions. Using rules in rational functions. So the next part that we are going to look at is looking at how do we expand the expression that they give us under rational functions. You simply say expanding expressions. Expanding expressions. How do we expand it? We expand by using what we call the rules. That is, we say important rules of limits. Important rules of rational limits. So that, learners, this is what we are going to look at. So you will be given the expression which is in form of a division, and then they ask you, can you simplify or can you eliminate the division, or can you find the value if at all there is a division in this relation. So we look at it, two important rules in this case of rational limits. One of it we say if n is a real positive number, a real positive number, a real positive number, then we shall have lim x approaches to a will be x raised to n minus a raised to n over x minus a, x minus a, x minus a. And then we have the second one, which is b. We say b if n, m are real positives, are real positive numbers, are real positive numbers. Then lim x is approaching to a will be x raised to n minus a raised to n over x raised to m minus a raised to m, which will give us n over m times a raised to n minus m. Then here we have na raised to n minus 1, where n is an index number, or a power, is an index or a power of a numerator, power of a numerator, power of a numerator. And then when you look at it, m is an index of the power of the denominator, power of a denominator. A denominator. So dear learners, I want you to understand these expressions. So when we are dealing with the divisions of rational functions, you will find that specific looking at how to expand the expression that you will be given. There are only two major rules that you are to follow. You may find a number where it is expressed in this form, x raised to n minus a raised to what? Raised to n. The numerator is powered and the denominator is containing a power of 1. So in this case, you are going to express that number or that function by looking at the power times a, which is now the base for the case here, or the real number, raised by n minus 1. And then if you come across a certain function where you find that both the numerator and the denominator are being what? They are containing powers. What are you going to do? And yet x is approaching to what? To a real number. For this case, x is approaching to a real number. But the fraction that is given contains, the numerator contains the power, the denominator contains the power. So you will express it as this, in this form. You will have n, which is the power of the numerator, over m times a raised to n minus m, where a is a power of the numerator and m is the power of the denominator. Once you have got those, you are able to interpret this formula, then you can easily be able to do what? To work out any expression where the both functions are powered when x is approaching to any real number. Let us look at the example. They say find the following. Find the following. Find the following. A they say lim x is approaching to 5. Lim x is approaching to 5 is x raised to 4 minus 5 raised to 4 over x minus 5. X minus 5. And then we have part B. Part B is x lim x approaches to x approaches to x approaches to x approaches to 2. X approaches to 2. And then here they say it is x raised to 4 minus 2 raised to 4 minus 16 minus 16 over x raised to 3 minus 2. So let us look at that example of part A and part B. So learners, when you look at this example, you find that if you've come across this kind of questions, then you just know that here I'm going to use what we call the rules of rational limits of a function. A rule of rational limits of a function. It depends now of the two. Which one are you going to use? You apply the rule basing on the type of the expression given to you. For example, part A, they say the x raised to 4 minus 5 raised to 4 over x minus 5. Meaning that now, in this case, you find that the numerator is powered and the denominator contains a power of 1. What are you going to do? You are going to apply the what we call the first rule, which is part A, which is expressed as x raised to n minus a raised to n divided by x minus a, which is n times a raised to n minus 1. So let us get the solution, or apply this two methods in these two examples. So you say solution. Part A, they have given us as lim x is approaching to what? To 5 is x raised to 4 minus 5 raised to 4 over x minus 5. Dear learners, what I want you to understand is that A will be as in your expression here. So where x is approaching will all the values of A will be where x is approaching. So then now we state our formula, which is lim x is approaching to A will be x raised to n minus A raised to n over x minus A. And now we have known that the value of A is 5 and the value of n is 5 is 4. Then now you'll have your answer, which is n A raised to n minus 1. So that is your formula. After that, you will now do what? Substitute. You say lim x is approaching to 5, which will give me now x raised to what? Raised to 4 minus 5 raised to 4 over x minus 5. And then now when I substitute this formula, I will automatically get 4 times A, which is 5 raised to what? Raised to n, which is 4, and then minus 1. So when we simplify what is in the bracket, then we get 4 times what? Times 5 raised to 3. So 5 raised to 3 means you are going to multiply 5 3 times to get that. And when we multiply 5 3 times, we get 125. So you will now have 4 times 125. 4 times 125, it will automatically give us what? It will now give us 500. It will give us 500. And then now you say, therefore, therefore lim x approaches to 5 will now give me x raised to 4 minus 5 raised to 4 over x minus A. So this will give me 500 as your answer. So that is your answer. Apply the rule depending on the expression given to you. And then now when we come to part B, learners, I want you to take that part B very serious, because it is very common, both for those who are taking additional and those who are taking basic mathematics. It is ever appearing in your national exams. Part B, the expression that is given to us, you'll find that we have x raised to 4 minus a multiple, which is 16, divided by 3 raised to x, is x raised to 3 minus what? Minus a multiple, which is 8. Now, learners, for this case, when you get a question of this kind, before you do any expression, you need to break this. Break the multiple which is given to you by factorizing it. And then, since it is all the both, numerator and denominator, the real numbers are multiple. So you factorize them first, and then now you can now be able to know which rule am I to apply. So you simply say, I will have lim x approaches toward 2, x approaches to 2 is x raised to 4 minus 16 over x raised to 3 minus 8. So what you do, you factorize 16 and 8. 16 and 8. So when you factorize 16 and 8, we simply use our what we call error and trial method. So factor 3. Factor 3 can give you the answer quickly. So when we break this, we get 2 times 8 will give us 16, and then we break this, we get 2 times what? Times 4 will give us 8. When we break 4, we get 2 times 2. So we find that 16 will give us 2 by 2 by 2 by 2. How many 2s are there? There are 4. So it means that when I get 2 raised to 4, I will get my answer as 16. And then you also do the same. You come to 18, 8. So you also break 8 by saying 8 times 4, and then when I break 4, I will get 2 by 2. So you will find that 8 will give us 2 times 2 by 2. How many 2s are there? 3. So this will give us 2 raised to 3. So you will find that the answer that you get, the value of A will be exactly where X is approaching. Then now you will now come and say, since I've got now my what? The factors. Then now I will say, therefore, leave X approaches to 2 will now be X raised to n minus A raised to n. For this reason, you find that all the 2, the denominator is also powered, the numerator is powered. Then you will have X raised to 3 to n minus A raised to m minus A raised to m, which is n over m times A raised to n minus m. Master this part here because it sometimes confuses learners. Instead of saying A raised to n minus m, you change A raised to m minus n, which is very wrong. So you will have now to substitute. You say lim X approaches to 2 will now be X raised to what? The power of the numerator is 4. Then minus A. We have got our A as 2. So you will say now 2 raised to 4 over X raised to m, which is 3, minus 2, which is power 3. So you will have this 3. So when we are to substitute this expression of ours, you will find that the power of the numerator is 4. So you will have 4 over the power of the denominator, which is 3. And then times A, which is 2. 2 power what? Power n. N is 4 minus m, which is 3. Then now from this we have 4 over 3 into 2 power 1. So it varies. Sometimes you may find the power greater than 1. So you simplify what is in the bracket before you multiply. So this will now simply get us 4 times 2 over 3 times 1. So our answer will be 8 out of 3. So this is our answer. So dear learners, when you follow those 2 rules and the steps that we have seen, you will be able to work out any rational function where x is raised to any real number. So with this, you will have to follow all these 2 examples. They will help you because they keep on varying. with these two examples, I hope you have picked something. And now I want you to do what? I want you to take these 2-3 questions and you try to work it out following the two examples. So they say find a limb x approaches to 4. X approaches to 4. We have x raised to 3 minus 4 raised to 3, and then over x raised to 2 minus 4 raised to 2. And then part B, we have limb x approaches to 2. X approaches to 2. We have x minus 2 over a root of x minus a root of 2. Last C, we have x approaches to 2. Limb x approaches to 2. And then we have x raised to 6 minus 64 over x minus 2. So dear learners, I want you to go and try those 3 questions. Following the 2 examples, you'll be able to work it out. We have now come to the end of our lesson for now, and I want to say goodbye for